Topic A, an introduction to Python. So I'm going to tell you a little bit about Python and why it's cool and interesting. So first up, Python's a high-level general purpose programming. High level means that you're not really dealing with zeros, ones, bits, and bytes. You're dealing with data from a high level using essentially tools that are pre-built. So it's harder to understand the details of what's going on, but it's easier to perform tasks. So you get a lot more done with fewer lines of code. So low-level languages would be like machine language, for example. So Python has a pseudocode-like syntax. So Python's been basically designed to be as easy to read as possible. And you have lots of things like curly braces in the beginning and end of code blocks being removed, the semicolons at the end of each line. There's no pointers like C has. So it's stripped down to be as easy to read as possible. Because of this, it's easier to write. It's also easier to maintain. And probably the most impressive thing about Python is sort of the resources that are built around it. So no matter what you're trying to do, there's probably going to be like a module or a library that you can import that basically performs a lot of those functions for you. So if you're trying to build a user interface, you can import a library called tkinter, and then you can use that to build the user interface rather than doing it from scratch. It makes things a lot easier. There's a lot of similar libraries, particularly in areas like machine learning and web development. Now, Python probably has a reputation for being the fastest development language out there. The idea here is it takes less time to make a program that does something meaningful for all of the reasons above. One, it's simple to write, to read. You have all these pre-built tools in the shape of libraries that you can use. And what was going to be my final point, you have real flexibility built into Python. So for example, you've got dynamic typing, which means you create variables, you can change their types dynamically. You also have the fact that Python is interpreted, which means you don't have to compile programs before you run them, which essentially runs them a lot quicker and gives you feedback in quicker time. So beyond this, Python also has the ability to be used in multiple programming paradigms. Now, paradigms are sort of very general, somewhat vague philosophical ideas about how we approach writing programs and solving problems with programs. So Python is probably most often used as part of the object-oriented paradigm. Object-oriented paradigm basically means that like you write programs that have classes which build objects. So these objects, they do stuff. They have attributes, they have like memory variables stored in them, they have functions, and they interact with each other. And it's a really good way to model the real world because, for example, like you're a car dealer and each car can be an object. Each customer can be an object. There are attributes of the car. There's also attributes of the customer, and that's how it works. Next, you got functional programming. Now, functional programming, this is like Python is quite often used, well, for data science, but also for science. And the idea of functional programming is you take data through functions, which then process that data. The data is ideally immutable, which means like unchangeable. So this is like basically writing programs that perform mathematical processes. Almost a subset of functional programming is procedural programming, which is the same thing without the tight definitions around using functions. You can use procedures, routines, and the data doesn't have to be mutable. Finally, you have this idea of imperative programming, and it's last because Python isn't used much for this, but imperative programming is really descriptive. So if object-oriented, you would get the idea of, what your program does. There would be classes and methods which are like black boxes, but you understand what they do. Imperative programming is understanding how a program does something. So you really are designing things from first principles. So finally, as a part of our intro, I'll give a note to Python 2 versus Python 3. So Python 2 was the previous implementation of Python. It's still out there. Unless you're actually hired and working to maintain a Python 2 code base, there's no reason why learn Python 2. But you should be aware that there are not major, relatively minor syntactic differences. The support for Python 2 code is still running, but the new features are not being added. So all the cool new stuff is basically being added to Python 3. In this course, we're going to be using Python 3.6. As of today, I believe Python 3.7 is out, but there's very few major differences. Some programs that we run in this course are not going to run on versions earlier than 3.3. I've done some testing, so if you have a Python installation that's earlier than version 3.3, I strongly suggest you upgrade. So to conclude our introduction to Python, I'm just going to bring in a Python program to give you a little bit of a taste of what Python looks like. So here, this is, I mentioned importing modules and packages. Time is a module. Time has certain methods that you can use. This is a print statement in Python. You can use single or double quotation marks. This here is a line that saves the user input as a string. This is a conversion, a type conversion from a string to an integer. That's a Boolean. Now this is a function inside time, or a method inside time. It sort of starts the clock ticking at 0 and it reads it again. And what this program does is actually test if a number is prime and then tells you how long that took. This is a for loop. This is an if statement. That's a break loop statement. That one checks the state of that Boolean. So what this program does is it basically divides the number by everything less than itself up to number 2. And if it can do that with no remainder, then that number is not a prime. So that's an example of Python code.